Hello and welcome to the CellCraft tutorial. In this tutorial, we'll guide you through installing CellCraft in CPU mode on an Apple Silicon Mac, which uses the ARM64 architecture. Let's start by checking the system requirements. Check your macOS version. macOS 10.15, Catalina or later is required. The current environment is Apple M1 Pro, macOS 14.6.1, Sonoma. Check your Docker version. A minimum of 20.10.0 is required, with 24.0.0 or later recommended, and check your Docker Compose version. Version 2.0.0 or later is required, with v2.20.0 or later recommended. Verify that Git is installed. Installation instructions for essential tools like Git and Docker are detailed in the Install Prerequisites section of the README. Since we're working in a pre-configured environment, we'll skip that step in this video. Now let's clone the CellCraft repository. The Recurse Submodules option ensures that the plugin submodule is cloned along with the main repository. And we need to configure the plugin submodule for CPU mode. Check the current submodule status. If you see head detached at, this means the correct branch has not been set yet. In this case, you need to use the git switch command to switch to the appropriate branch for your installation mode. Since ARM64 environments cannot use GPU acceleration, we'll use the release/plugins-v 1.0-CPU branch designed for CPU mode. Let's pre-download the Docker images. When the script runs, a menu will appear. Select option 4 to download the CPU mode images. The image download will proceed. This may take some time depending on your network speed. Once the download is complete, run the script again and select option 1 to verify that the CPU mode images were installed correctly. When all images show local yes, the download is complete. Now let's start CellCraft. Since we're using ARM64 CPU mode, we'll run the CPU mode script. The script automatically detects the ARM64 architecture and uses the appropriate Docker Compose file. Let's first check the installation status. This script verifies that all 5 required services, front-end, back-end, DB, RabbitMQ, and Celery are running properly. As you can see, script now shows errors indicating that the backend API check has failed and the plugin image download is not yet complete. This is expected at this stage. First, let's check the container status. All containers should show up status if everything is working correctly. Next, let's check the HTTP connectivity. The front end should be accessible immediately, but the backend will only respond properly after the plugin initialization is complete. The backend service is currently downloading the plugin Docker images. On the first startup, this download typically takes about 10 to 15 minutes depending on your network speed. While the download is in progress, you can access the web interface at localhost:8080, but backend API features like sign-up, login, and workflow execution will not be available until the plugin initialization is complete. You can monitor the download progress in real time through the backend logs. When you see 4 Docker images check in the logs, you can track the download progress of each plugin image. In CPU mode, a total of 6 plugins will be downloaded: Genie 3, Jiren Boost 2, grnviz, Leap, Scribe, and Tenet. When you see the message UVacorn running on HTTP, 0.0.0.0:8000 in the logs, the plugin initialization is complete. Then let's wait until the download finishes. Once the download is complete, run the installation check script again. You should now see that the backend service and all plugin image downloads have completed successfully. And when you can successfully access the backend API documentation at localhost:8000/docs, the CellCraft installation is complete. Now access the frontend at localhost:8080. This concludes the CellCraft CPU mode installation on macOS ARM64. In CPU mode, you can perform GRN analysis using 6 plugins: Genie 3, GRN Boost 2, GRN Viz, Leap, Scribe, and Tenet. For detailed usage instructions, please refer to our other tutorial videos. Thank you for watching.